All right, algebra, we are unit 6, lesson 10, graphs of functions in standard and factored forms. Let's do a warm-up. So here's a graph of the equation y equals 8 minus 2x. We are used to seeing this in the form y equals negative 2x plus 8, where we know this is the slope and that is the y-intercept. We see the y-intercept right there, and the slope is going down 2 over 1, down 2 over 1, down 2 over 1, okay? So where do you see the 8 from the equation in the graph? It is the y-intercept. So its value is 0, 8. That's where the x-coordinate is 0 and the y is 8. Where do you see the negative 2? It's the slope. We're going to say negative 2 over 1 or 2 over negative 1. It does not matter. And then 3, what is the x-intercept to the graph? Right there, 4, 0. How does this relate to the equation? Well, if I plug 0 in for y, and then I solve for the x, I have 2x equals 8. Divide both sides by 2. X equals 4. X equals 4 when y equals 0 is how we get 4, 0. So 3 very important parts of linear equations in this warm-up. All right, let's see how we can apply this. So revisiting projectile motion. In an earlier lesson, we saw that an equation such as h of t equals 10 plus 78t minus 16t squared can model the height of an object thrown upward from the height of 10 feet with vertical velocity of 78 feet per second. That means that I'm standing on, I don't know, a ledge 10 feet from the ground, and I launch something up at 78 feet per second. Okay, this 16 relates to gravity. This is your velocity, and that is your starting point. That's what we see here and there too. So is the expression 10 plus 78t minus 16t squared written in standard form? Well, we prefer the t squared to go first. Even if it's a negative leading, that's just how it's preferred. So that is standard form because I don't have any groups of binomials. There's no parentheses. I've got ABC form, right? So I have a squared term, I have a to the first power term, and I have a constant term. My A is negative 16, my B is 78, my C is 10, etc. So I would say yes, it's written in standard form. It's just preferable to be in a different order. 2. Jada said the equation negative 16t minus 2 and t minus 5 also defines the same function written in factored form. Show that Jada is correct. Well, just like we did in last lesson, I'm going to FOIL these two binomials. So first times first, inner, outer. I got 16 times 5 gives me, it's a negative times a negative, so that's a plus 80. And then last, plus 10. If I collect like terms in the middle, I get negative 16t squared plus 78t plus 10. So yes, that factored form is the same as the standard form. Those are equivalent. Here's a graph representing both the factored form and the standard form. Identify or approximate the vertical and horizontal intercepts. So if I look right here, let me change colors. the vertical intercept is 10. And I actually know that because of the constant in my standard form. Okay, that is where we're throwing the projectile object from 10 feet above the ground, right? And then this is the horizontal intercept, and this represents the time when the object reaches the ground. Right? So we start at time 0, we end at time 5, I assume seconds. It didn't, yep, feet per second, so seconds. We start at 0 seconds, end at 5 seconds, and we start throwing it from 10 feet above the ground. Okay, so we got A and we got B. What do these points mean? We also know what that point means too, don't we? That's the maximum height, which happens at about 2.5 seconds, a height of, I don't know, 105 feet, approximately. So relating expressions and their graphs. Here are pairs of expressions in standard and factored forms. Each pair of expressions define the same quadratic function, which can be represented with the given graph. Identify the x-intercepts and the y-intercept of each graph. So here we have 2 x-intercepts and 1 y-intercept. I'm actually going to move this over here so I can write. So in this graph, the x-intercepts are where it crosses the x-axis. It looks like a -3 and a -1. The y-intercept is where it crosses the y-axis, and that looks to be like a 3. Identify, that's it. What I'd like to point out here is this first graph, or sorry, the factored form. I see a 3 and a 1. What we're actually doing here is setting if this were equal to 0, that means x plus 3 equals 0. Sorry, let me erase that. X plus 3 should equal 0, or x plus 1 equals 0. And if I solve those, I get -3 or -1, which is where this comes from. The other thing that's cool is if I look at standard form, that's my constant. So if x is 0 and y is 0, which is right there on the graph, my constant is 3. So standard form tells us what the y-intercept is, and factored form tells us what the x-intercepts are. Let's look at function g. My y-intercept is 4, and my x-intercepts are 1 and 4. If I look, let's see, let's do, that should be yellow, 1 and 4. If I look at the factored form, okay, x minus 4 equals 0, or x minus 1 equals 0. So x equals 4 or x equals 1, which is what we get here. And then my constant on my standard form shows me the y-intercept. Oh, there's more. Okay, we're not going to go through each step like we did in the last one. If I go here, it looks like my x-intercepts are going to be 3 and -3. My y-intercept is going to be a -9, -9, -3, and 3. Okay. Here it looks like my intercepts are going to be 0 and 5. My y-intercept is going to be 0, and let's look at how it shows up. Yep, 0 and 5 and 0. Again, x equals, wait, I'm going to rewrite that, -x squared plus 5x plus 0, so my y-intercept is 0, and same thing, 0 and 5. The difference here is very important, which we are going to review again. Function j, I have a leading negative, which makes for an unhappy parabola. Function I have a leading positive, which makes for a happy parabola. Okay, that's important. And one more. Sorry, oh gosh, didn't mean to do that. So we have function k, looks like my y-intercept is 4, and my x-intercept is -2, both -2's, which is true. Okay, that would be x plus 2 equals 0, so x equals -2. So we only have one x-intercept. So what do you notice about the x-intercepts, the y-intercept, and the numbers in the expressions defining each function? Make a couple of observations. We did that along the way. Okay, on purpose. I thought it'd be easier to go along the way than to go back and do all that, right? So here is an expression that models function p, another quadratic function. Predict the x-intercepts and the y-intercept on the graph that represent this function. So I can say x minus 9 equals 0, or x minus 1 equals 0. So x equals 9, x equals 1. So those are my x-intercepts. Now the y-intercept, I just want the constant. So if I actually take the last terms of the binomial and multiply them together, I get a positive 9, which is also going to be my y-intercept. So if I graphed this, I would get a point at 9, a point at 1, and another point up here at 9. And it would look something like that. Pretty cool. Awesome. Good job.